Where these data?
Snapshot.
It was a snapshot, good, which is a non-mathematical term for a sample, right? That's the idea. This is not the population. This is something that was drawn from a simple little random data set. There are plenty of other ways a laptop can be damaged that are indicated here. That's what makes it a problem for a probability distribution. The distribution has to list everything that possibly can happen. And it should be quantitative, not qualitative data. So we can actually do something with it, like find a standard deviation, find an average. Jess, does that make sense? Very good, my friend, very good. It's a little misleading because these sums to 100%. So you're like, oh, it's golden. Well, only if you actually have everything over here and you don't. Could we just put numbers on these? Yes, you could. You could call that 0, 1, 2, 3, and then find an average. Would that number mean anything?
No.
No, it would mean absolutely nothing. It's an average of 1.8. And what would that mean? Nothing. It would mean nothing. 1.8 what? That means I kind of dropped it, but didn't quite not protect it for travel? That's silly, right? That's silly. What if you called this 0? 0, 1, 2, 3. Oh, no, it's 2.2. You see what I'm saying? It doesn't make any sense to number these data. It's qualitative. As such, sorry, these are the jokes, kids. As such, you can't do anything except look at the mode. Chester, fair? Good. Thank you, friends. Thank you. Go ahead.
Number 10, it says test the following function to determine whether it's a probability function. How do you
Well, check it out. What's the function?
R of x equals 0.2 or x equals 0, 1, 2, 3, 4.
Wait, R of x
Equals 0.2.
0.2 for x equals
0 through 4.
1, 2, 3, 4. Check this out. We can do this without even writing the table now. I would approach this like I approached number, is that an 8?
Yeah.
Okay, good. That was my artistic fade, I apologize. We can approach this just like that. Let's set that table up in our mind. All right? It's going to look like this. Except for some reason they call this R of x instead of P of x. No big deal. So this column goes from 0 to 4. 0, 1, 2, 3, 4, which has 5 elements in it, correct? 5 elements. 0, 1, 2, 3, 4. I don't know what that stands for. I don't know what it stands for, but it stands for something that's quantitative. Something to be counted. 0, 1, 2, 3, and 4. How about the probabilities? What are the probabilities for each of those? According to this function, they are 20%. So what's the chance of, now going off 0, 20%. 1, 20%. 2, 20%. 3, 20%. 4, 20%. Is that a distribution? Hell yeah it is, because what do those probabilities sum to? There are 5 of them, times 0.2, that's the sum of 100. Boom. And it's numerical data in the left, we're golden. We're golden. Numerical data in the left is guaranteed right here. That multiplied 5 times gives you 100%. Yes, it's a distribution. That's actually a perfect practice example for your out-of-class exam next week. I'll have you in Excel doing these kinds of things, where you actually use Excel to drag the functions down and create them from scratch. So plus it gets you in Excel, messing around with Excel. So yeah, perfect. Cool? Now, ready for this? How about now? How about now? Is that a distribution? For those of you that weren't looking when I did that, I'm sorry. I erased 4. Is that a distribution now? No, because the sum of the probabilities sums to 80%. Now it is. See what we're getting at here, friends? See what we're getting at? You see what I'm getting at here? Tell me when to stop to make it a distribution. See, I changed to 0.1, 10%. Tell me when to stop adding variables to make it a distribution.
9.
Just tell me when to stop. I'm going to keep writing.
9.
Tell me when to stop. Stop! That's what I wanted to hear, David. See the point? Now these are all uniform distributions, which means all the probabilities are the same for every random variable. It's way more interesting when they're not uniform, which we're going to get into today, I promise. But what this, no, don't frown, Sarah. It's not bad. It's not bad. There's a reason I'm taking it one step at a time, because I want to build up to this deal. And what we're going to do today after our exam review is not going to be on your exam Wednesday, it'll be the last exam. So we start today, we'll not screw you up for Wednesday. If anything, it'll give you more practice as far as finding averages of distributions. But as far as creating the distributions from scratch, we're now starting to get into that. Rather than just holding down an F9 button all the time in Excel to create probabilities, we're going to show how to get them from scratch ourselves. Fair? Yeah, good. All right, let's chit chat about your exam a little bit. Let me slide this to the front here. You guys picked some awesome ones today. Let's do this.
Did the daytime choose different questions?
They did, and I have the posted for you. Yes, Dave, that's a great question. Did the daytime class pick, the earlier class, 10:15, pick different homework questions to go over? And they did. You guys picked completely different homework questions. Have anybody been doing that? Watching the earlier classes videos to get the other homework? Because whenever we have homework to go over, almost never do you guys pick the same ones. It's amazing to me. It blows my mind. I think maybe 2 or 3% of the time do you guys pick the same questions. You guys always seem to pick different ones, which is great. It gives you another resource. So you can actually watch both videos from both the classes, which is pretty cool. All right. So, we have 3 sections. Relative position. Yes. The magic of outliers. Yes. And probability distributions. Yes.
So are you going to find the outliers, or are you going to want us to know?
Hold that thought.
Okay.
Hold that thought, David, because I'm going to answer it 2 ways. In writing, I'm going to answer it for Wednesday's exam. Has anybody looked at the out-of-class exam yet? I'm going to mention, I posted it yesterday afternoon, so I sent you an email today that's posted ready for you guys for next week. I'm going to mention verbally about the out-of-class and write down about the in-class. Is that fair? So I'll get to that question, I promise. Let's start over here, just because we were just here. As this is just the in-class exam for Wednesday. As far as what you have to know here, you already saw it today. You have to know how to find the average and the standard deviation of a distribution. I don't expect you to do it manually. By all means, I will happily put the formula for that on the board if you don't want to memorize it. Happily. I expect you to use L1, L2, 1-bar stats. But I'll happily put the formula on the board if you want to have it up there. Okay? And the only other thing you have to remember for the in-class part is that the sum of those probabilities is 100%. That's it. You got those 2 things, you've got that section's problem done. You essentially reviewed for that problem today with the questions you guys asked on the board. And essentially. I can change the distribution. Does that matter? If I change the distribution? No. You're still going to run 1-bar stats to find the average and the standard deviation. And they still have to sum to 100%. It doesn't matter how goofy the distribution is. It doesn't matter at all. Austin, go ahead.
Just one last time, what was the sideways 6?
What is the sideways 6?
Is that sigma?
That's little sigma, which is the standard deviation of the population. Yep. Now that's sideways 6, yes. And I tend to draw it wrong when I draw it by hand. It shouldn't have that little kink in it. It should be like that. Kind of ish. Not quite. A little excessive. Sorry. Fair? Okay, that's all you gotta know for the in-class part. The out-of-class part has an Excel component to it. It's got some more rich discussion, but it's an out-of-class part. You got plenty of time to work on it. For the in-class part, I want to put your minds at ease. You have the skill set, and that's what you have to know for Wednesday. You know it already, which is great, which is fantastic. Okay, outliers. David asked a great question about outliers. For the out-of-class part, what I did was I looked at all the lengths of all my last names of all my 243 students, you guys in the 1015 class, and I made a distribution of all of your last name lengths. I think the shortest I have is a couple of 3-letter people with 3 letters in their last name. I think the longest one is 12. And you can make a distribution of all those last name lengths. And I asked you to find what, if any, are the unusually long or short names. Using any method you prefer, but you have to justify why you used it. Draw me a graph, 2 graphs. I think I actually asked for 2 graphs, a bell graph, a histogram. If you choose to use that one. That's the whole thing. It's very open-ended. You choose. If you want to use the 5% rule, the 95% usual, 5% outside. If you want to use the modified box plot, the IQR, it's up to you. But you have to supply a couple graphs to justify your choice. But it takes some time. Hence, not on the in-class part. I don't want you worrying about that on the in-class part. For the in-class part, focus in that homework assignment. There were only like 5 questions in that homework assignment. Focus only on the one that dealt with the margin of error in the study. And if I remember correctly, it was about type 2 diabetes. Diabetes.
I'm sorry, I love
With a
it.
numeral out?
What's that guy's name?
I don't know. Oh, Wilford Brimley.
Wilford Brimley.
Age of Quaker Oats.
Yeah, the diabetes.
Type 2 diabetes and TV watching. Remember that one? Type 2 diabetes, TV watching. There was something about heart disease in there as well. So focus on that, make sure you can attack that problem. You will notice a beautiful correlation between that problem and another margin of error question from your first in-class exam. I did that intentionally. I found another study that had the margins of error attached to it, but it ties into the idea of outliers. And in the homework, you'll actually see that. You'll see how it ties in. So if you didn't get a chance to do that yet, go back and look at that one. And you'll see how it just follows directly from that. Cool? Awesome. And last but not least, relative position. I'm not going to ask you to do a bunch of calculations for this. You're not going to calculate percentiles or anything like that. On the out-of-class exam, we actually go in and analyze the different ways to define percentile rank. I told you guys there's more than one way people use to define it. Let's not worry about that on the in-class exam when you're already nervous. Out of class, great place to worry about it. I say worry about it, great place to explore it. For this one, just look at questions E1 through E7 in the homework. Part of those is pulling percentiles from articles. You might remember this one from your homework. It was the one where we had weight gain after smoking. 20%, 80% of all people gain some weight after smoking. 10% gain 25 pounds or more, or something like that. I'm making this up because I don't remember. And the idea was pulling percentiles from those words. No mathematics involved, just simply pulling the percentiles and making sure you know which way we're going up or down. And the last bit, I think that's like E1 through E3. The last bit is comparative box plots. That's when you got a bunch of box plots together, and you're trying to see which one has the larger maximum, which one has the larger median, what percentage is between blah and blah, that kind of a thing. Identifying outliers on a box plot, a little special symbol. That's your class exam, friends. I'm not designing it to be tricky. I'm designing it for you to kick its ass. Because I want that. Yes? It's not going to be a bunch of formulas memorized. It's a bunch of ideas applied. A bunch of ideas applied. I haven't decided which comparative box plot we're going to do yet. I'm thinking either miles per gallon cars, delays in not miles per gallon cars? Do not do that.
I hate that.
You hate that. Why do you hate that?
I don't know. For some reason, I just hate that. I always have on word problems. It's the worst.
Wow. I'm strongly about it.
What are the other options?
Well, I don't know. I mean, I'm all worried about this one now.
No, don't worry about it. Remember what else
I was thinking flight delays at an airport, maybe. Miles per gallon in car. What if I had a really good miles per gallon data set? Like cross-country data
As
set.
long as it's not like the one for either the project that we had to turn in or whatever, where we had to figure out how fast you were running during your victories. I hated that. I gotta agree. That was the worst.
No, it will not be nothing like that, my friend. There's going to be almost zero mathematics, all I'm talking about doing right here.
Okay, cool.
Yes, so, okay. That was the worst? The worst?
It was pretty terrible.
Pretty terrible?
It took me a while, yeah. I don't know if it's just because I struggled in that area, but yeah.
No, you know what it is? I think it has to do with something I was talking to my department chair about this morning. The mathematics involved in that math right there, in that problem you had to do for that, is arithmetic. But we have arithmetic you guys out by forcing you to learn algebra for the past 12 years of your lives. Nah, not 12, 6 years of your lives. Ever since you turned like 7th and 8th grade until now, we have ruined you guys by making you factor quadratics and solve exponential equations by hand and rationalize the denominator. We have ruined you guys mathematically because that right there is real math. Here's why. Me and Max, give you an example. Me and Max were building you guys in the 105, I did this problem in my 105 class. My son and I were building a tadpole pond last year. And we were trying to figure out how big a waterfall he wanted in the pond. So it's a little tiny pond, I mean, maybe 100 gallons or less. And it had one of those big pieces of basalt with a scoop top. And I had the hose in my hand. I'm like, Max, what do you think of this? And I put the hose down on the top, and it filled the top and then overflowed into the pond. He's like, that's awesome, Daddy. And I'm like, sweet. I'm like, hand me that Nalgene over there. Grab the Nalgene. I was like, Max, when I say go, push that button on my watch. When I say stop, push it again. Okay. Go. Put the hose in the bottle. Stop. What does it say? 2.2. In 2.2 seconds, it filled the quart. And I thought for a second, I'm like, okay, we need a 400 gallon an hour pump. That mathematics is the same mathematics you guys had to use in that problem. That's real mathematics. That's mathematics that actually occurs to use in a daily basis, depending on what you're, I mean, maybe not, maybe never, But I'm standing in my yard building a pond with my son, and I have to figure out how big a pump to put on the tadpole pond, and I have to use arithmetic. And it breaks my heart to hear that that was terrible, because I found a pure joy in doing that problem because it's such a refreshing change from solve for x. Factor this freaking quadratic again. Difference of 2 cubes. Oh yeah, it's that formula I had to memorize back in 7th grade. That just breaks my heart to hear students when they have a hard time relating to that. And they should have a hard time relating to it. It's not real.
I would have rather done the quadratic.
Oh, sweet Jesus. That's only because we've broken your spirit, Cassie. We'll build it back up, my friend, I promise. But not right now. Right now you're going to take 5. And go stand outside this beautiful windy day. And careful not to get blown away by this beautiful windy day.